Welcome back to another CloudCompare tutorial. Today we're going to be talking about point cloud extraction. So this is how we kind of take one point cloud and break it up into component pieces or smaller pieces. And so there's a couple of different ways we can do this. One is with what's called the segment tool. So this is literally kind of chopping up the point cloud into different bits. The second way we can do this is kind of a little bit more non-destructively with what CloudCompare calls the cross-section tool. And then the last method that we'll go over today is filtering by a scalar field or an attribute. So this is where we can take kind of a range of elevations and extract out just that specific range of elevations, or with LiDAR data, different classifications. So the first thing we're going to want to do is get some data loaded. I'm going to go ahead and use the Sandy River LiDAR data set that we used in the last tutorial. So again, accept kind of the defaults on opening the last file, and then again, we'll just accept the defaults on the global shift and scale here. So now that we've got that loaded up, we can go ahead and close out our console window here down at the bottom to give us a little bit more space. And the LiDAR dataset comes in again with kind of the default first scalar field that it has in its dataset, which is point source ID. That's not, again, very useful for us. So I'm going to go ahead and add in the Z values as color. So again, that's tools, projection, export coordinates to scalar field, the Z values, okay. And then I'm going to change my color ramp down here to a custom color ramp that I've got a temperature color ramp, just to give us a little bit more definition in all of those elevations. So before you get started on any kind of point cloud extraction, it's usually a good idea to make a clone of your point cloud within CloudCompare. Now, the good thing about a lot of the editing that we can do and the extraction that we can do in CloudCompare is that it's not destructive to the original file, which is good, unless you kind of save over it, which takes some effort. But the base kind of operations that you can do in CloudCompare are non-destructive. So you can edit and change, and if it doesn't work, you can just remove it from your DB tree and reload the data, and it'll be just fine. But to save yourself some headache and wait time on reloading the data, oftentimes I'll clone a data set first before I start editing it, just so that I don't have to waste time reloading the data. So in order to clone a data set, so you click on the point cloud that you want to clone, and we'll go up to the little double sheep icon up here. So clone the selected entities, and so that will make a second copy. And since this is a big point cloud, that takes a minute. But in the DB tree here now, you can see that this has a suffix on it that says .clone. So that's the cloned data set. So you can actually edit either one of these. I usually go ahead and edit the clone so that the original's left intact for now. So we're going to go ahead and select that cloned data set as our target for our editing. And the first way that we're going to try to break up this point cloud is with the segmentation tool. So the segmentation tool is the little pair of scissors up on your toolbar. So if you click on that, that will open up kind of the sub toolbar up here in the upper right. And you can see that the text on the screen says segmentation on, polygonal selection, left click to add contour points, right click to close. So this is kind of giving you some prompts as to how this tool works. So I'm going to show you two different modes of operation. One is just a single cut, and then the second is doing what's called a multiple cut, or multiple selections to extract out. So in order to just do a single cut on this, what you're going to want to do is select the polygon selection tool up here, okay, which is usually selected by default, but I usually like to just double check that. And then what you want to do is left click on kind of points to describe a polygon that you're going to want to cut out or cut in. And we'll talk about the difference between those in just a second. So in clicking on the scene here, and usually I do this from the top-down perspective, you'll start to see the first left click, you'll get this green line that starts to be pulled out from your cursor. And as you click around, you'll see that that starts to form a kind of polygon that kind of self-closes. And so in this case, I'm just going to go ahead and do a quick digitize of the river bottom here so that we can extract out just the river bottom. I'm not being too careful. You can be as careful or as kind of generous as you like with your digitizing. And so we're going to click around till we get back to the beginning, and you can see since this auto closes, we don't have to find the original start point. But if we right click, you can see that that green line snaps away from our cursor, and so we have this polygon. Now there's two different ways to segment the point cloud. So one is what's called segment in, and the other is segment out, and we'll play with both of these. So first we'll do segment in, and so this segments out everything that's inside the polygon. So if you click on that, and then we'll hit the confirm segmentation button over here. What you'll see is that we end up with kind of two separate new point clouds over here. One is called remaining and the other is called segmented. And so if we click these on and off, I have my original point cloud still on. So the segmented point cloud is what you had inside the polygon, and the remaining point cloud is everything outside of that polygon. So that's what the segment in does. The segment out tool would just do the reverse. So you'd actually, the segmented would be the outside and the remaining would be the inside. Either way, it works just about the same. I usually go for inside since that's kind of the way I'm familiar with digitizing, is I want to kind of select everything inside the polygon, but you can do it either way. So I'm going to go ahead and delete those real quick, and we'll start over with a new clone. And I'll show you how we can actually do multiple cuts in one segmentation session. So that if you do want to actually do multiple kind of cutouts, you can actually do this in one go. You don't have to do segments on top of segments on top of segments. So we're going to select that clone, click our scissor segment tool again. And so in this case, we're actually, instead of using segment in, we're going to actually use segment out in order to do this selection properly. So I'm just going to pick a couple of spots along the river to show you how this works, but you can do this again in as many or as few as you want. So what I'm going to do is just select the upper left portion of the river here, right click to close that, and then I'm going to say I'm going to click on the segment out tool here, and that'll pull out that data set, and you can see that this says segmentation paused. And if I move the point cloud down, you can see the rest of the text says unpause to segment again. So what you can do in the sub toolbar here is unclick the pause button to allow you to make another selection. And so right now we'll just click down and digitize another set of points down here, right click to close. We'll say segment out again. And now you can see we've got both of those cut out, and we'll do one more. So unpause, left click, left click, left click, left click, and then right click to close, segment out. And once we're done with all of our selections here, again, we'll just hit the green confirm selection, or confirm segmentation tool option here. And that will go through and pull out those parts that we cut out and leave behind the parts that we wanted to leave in. So in this case, again, it'll keep both of the point clouds active. And so if you click the segmented, that'll be everything that's left since we did the out, segment out option. And then the remaining is the inside portions. So this is just one way to kind of segment out multiple sections of a point cloud in one kind of session rather than having to do multiple selections as you go. Now, one thing I will kind of warn you about is that if you try to do too many of these, oftentimes you will get some hiccups, and I've had CloudCompare kind of freeze up. Not too often, but again, if you start selecting lots and lots of points with lots of multiple selections, you can run into some problems. So I would do a few segmentations and then do a few more if you're doing a lot of kind of small segmentations. Another interesting thing that you can do with the segmentation tool is that you can actually load in predefined polygons as well. And I don't have one for this site specifically set up, but I will show you how you would do that. Is that you would load in a shapefile or some other pre-existing kind of polygon feature. And in the segmentation tool, you can use there's the little line icon here, which is use existing polyline. And if you had a polyline in your database tree, you could actually use that to make your selection as well. So if you have a shapefile for a study area or a pre-existing kind of polyline in CloudCompare, you can go ahead and reuse that again and again. Which is pretty slick. So the next thing that we're going to look at is the cross-section tool. And so this is pretty handy for a number of different kind of applications. And the obvious one is to make a cross-section properly. So in a lot of kind of digital terrain analysis, looking at a cross-section of a landscape is a good way to kind of get a feel for how the landscape is structured. And so the way that we do that is with the what's called the cross-section tool up here in your toolbar, so about 2 to the right from your scissor tool. So if you click on that, that'll bring up a number of different handles on your point cloud. And if we rotate around here, you can see that we have kind of different handles in all 3 of the major axes. So we have red as the x-axis, green as the y-axis, and blue as the z-axis. And so these handles are ways that we can kind of manipulate the yellow box here, the field of view or the area of interest, and kind of clip out a very specific section. So you can make this very thin, you can make it big and blocky. And so if you do this in a big blocky section, you can extract out just that section. But if you actually want to do a proper cross-section, so let's say we wanted to do a cross-section for this low section of the river here, what we can do is get a real narrow slice up here, and I'll show you how to do this kind of a little bit more quantitatively in a minute. But you can get a really narrow slice here, and then over in the options box over here, you can actually say export selection to new cloud. So if we click on that, over in our database tree, you can see that we have a new cloud entity over there. So if I close this out, the original cloud pops back to normal. And so I can turn that off, and what we're left with is just that small little selection that we made down here. So I'm going to actually reset our rotation center to the river there. And if we rotate this down to a front view, now you can see that that is a proper cross-section of the river. So from the hilltop over here, down into the valley, down to the river bottom, and then up onto kind of the floodplain here on the left, or the right-hand side, excuse me, and then back up, starting to go up a hill here on the right side. So that's one way to get a kind of proper cross-section analysis. And so this is its own independent point cloud now, so you could do analysis on that, or you can edit that as you see fit. I'm going to go ahead and delete that for now so that we can look at another couple of different options in that cross-section tool again. So again, I'm going to select that clone, hit the cross-section tool. And so the other thing that you can do with these handles is rotate them as well. So you can go in and out, but then the little circular toroidal kind of handles here. So around the arrows themselves are kind of the push and pull handles, but then the little round donuts here allow you to rotate that area of interest as well. So you can rotate that in all the different axes, and that'll give you some interesting things, interesting results. In most landscape data, you're not going to want to rotate X and Y, the red and green. You may want to rotate the Z-axis, but you may have need for rotation on the X and Y as well. So I've kind of screwed this one up, so I'm actually going to hit the X out of that, close that out, and start a new cross-section. Go back to my top-down view. And so one way that you can do a little bit more kind of quantitative cross-sectioning is if you click over here in the Advanced tab, or the Advanced options, you can see that you can actually define this area of interest box by its center. So you can actually type in coordinates for the center, and then the important thing here is the widths. So in the X direction we have almost 1,000 meters. In the Y direction we have 70 meters right now, and in the Z direction we're encompassing about 208 meters. But let's say we wanted to actually get a very specific cross-section width or height extracted, and so you can actually type in a number there. So in this case I'm going to type in 10, and you'll see that if I hit OK, that narrows the Y direction down to a very narrow 10 meter strip, a very precise 10 meter strip. So that's one way to get a little bit more precise. If you need a very specific dimension on this cross-section tool, you can use the Advanced tab there. Now, another interesting thing, let's go ahead and extract that out real quick and close this out. And let's say you had another point cloud that you wanted to extract the same cross-section from. So I'm just going to reuse that same point cloud, but you can click on your second point cloud that you want to extract that same cross-section. And if we go into cross-section and then click on Advanced again, then you'll see that there's a new button in here. I know you were all paying attention before, but this last button is new after we did that last advanced selection. So if I click last, what that will do is actually match the center coordinates and the widths to the last selection that we did. So we'll hit OK, and that puts it in the exact same spot as we had before, and we can extract out that point cloud from our second data set. And then if we wanted to compare those two, we could do so in the same space. So those two cross sections here, so section and section, are the exact same size. So that's pretty handy for comparing two different data sets from different timestamps or two different temporal events. So pretty handy with the cross-section tool there. Like I said, you can do as big or as small of a cross-section as you need. So the last thing that we're going to do is to extract by or filter by scalar values. And so this is a pretty straightforward process. The only kind of prerequisite is that you have to kind of define what you want beforehand and know what you want beforehand. And so in this case, I'm going to do a couple of different extractions to show you a couple of different methods here. And so in the last video, we looked at the classifications on this point cloud. So again, this one has a classification of 1 being unclassified and 2 being classified as the ground. And so in this case, if we wanted to extract out just the ground points from the rest of the data set, we can do that with a filter by scalar value selection. So in this case, I'm going to select this data set. I've switched it over to the classification scalar field so that we can get a view of it. And then up here in your toolbar, there's, by the histogram tools that we looked at in the last video, there's this little toolbar right here that looks like the color ramp with a min-max on it. So I've got it highlighted there. So if you click on that tool, this brings up a filter by value dialog, and what we can do here is put in the values that we want to extract, or the range of values that we want to extract. So in this case, our classification just goes from 1 to 2, and so what we want is a range of 2 to 2 for the ground points, and then the remaining points, the unclassified points, won't be included in that selection. So there's a couple of different options here that you can do to extract. One is to export just the points inside that range. So in this case, it would just export the ground points. Or there is an option to split the point cloud into two different clouds so that it would create basically all the points with the classification of 1 and all the other points with the classification of 2 as two different point clouds. Most times I just use the export tool just to get the ones that I want, since those are the ones I'm after, but the split can be useful in certain situations. So we'll go ahead and hit export, and now you can see that we have a new entity here in our DB tree that says has a new suffix on it. So this is clone, which is it came from the clone data set, but then you can see that it's extract, and so that tells you that it's been extracted from the clone data set. So one thing that you'll learn about CloudCompare is that it likes to put on these suffixes as you do different elements and do different analysis tasks, and so it's a good way to keep track of kind of the custody chain or the processing chain that you've done on these. Sometimes these do get a little bit long and unruly, and you can kind of trim them back if you need to, but usually I just leave them as they are. So you can see here that we're left with just the blue points, which are our ground points. And so if I switch back to our z values and we rotate down, you can see that we're just left with the ground points here in this case. So this isn't like we did in the last video. This isn't just kind of hiding all of the other points. This is literally just the ground points. And so you can see that here with our point count over in our properties window. This is only 525,000 points versus our full point cloud is just over 12 million points. So about a third of the points are classified as ground in this case. So that's one option to do this, is to do extracting by a scalar field. I'm going to show you another example of that by just extracting a certain elevation value. And so in order to do that, one of the things I want to do is go ahead and do a little bit of an advanced analysis step here. What I actually need to do in this case is, let's say I want to actually filter by height above the ground. Now, in this case, we don't actually know what the height above the ground surface really is. We just have absolute elevations in our point cloud. But what we can do, since we extracted out the ground points here, is that we can actually create a surface from these ground points and then measure the distance to that surface in the original point cloud. So I've got a tutorial on my my website on how to do this in a little bit more depth, but I'll go through this pretty quickly. So in this case, we're going to want to create a mesh surface from our ground points here. So in this case, we'll do edit, mesh, and then we're just going to do a Delaunay mesh in the XY plane. Max edge length, I usually leave it 0 for most analysis tasks like this. So that will triangulate a mesh surface that kind of covers all of those ground points. So this creates a solid kind of surface that we can measure to with our kind of full point cloud. So in this case, we're going to use a tool up on the top here called Cloud to Mesh Distance. So I'm going to select my point cloud, hold down Control, and then select my mesh surface. And then the tool up here becomes active. Okay, so there's this tool up here that is points to a mesh. Okay, so a pretty intuitive icon there. So if we click that, you can see that it automatically populates here to say the point cloud is our compared value, and then our reference surface is the mesh. And then most of the time you can just leave the defaults here. There are some advanced options if you're interested in those, but the defaults work for most cases. So all you have to do is hit the compute button down here. And if you have a large data set, this can take a while since it's actually measuring distances from each point to that surface. All right, so that took about 8 minutes to calculate all of those point distances. So once the progress bar goes away on the screen, don't hit compute again because that will recompute the values. So you can go ahead and say OK. And so in this case, if we turn off our mesh and just look at our point cloud, you can see down in our active scalar fields, we have a new scalar field here called C2M signed distances. So this is cloud to meshed signed distances. And if you go down to the bottom here, you can see that we have kind of a little bit of a weird histogram. We have a lot of data that's at 0, and then a few points, probably 1 or 2, or just a handful of points that are lower than the mesh. And so in this case, this is a good point where we can actually pull this up to the display value up to 0, basically, so that we're not showing those values. And then we can also change our saturation here from the lowest value, minus 39 in this case, up to 0. So that gives us our 0 value right at the ground surface. And then we can also pull down our top saturation value so that we can actually see some of the upper values here. So this is in meters, and so we're basically going from the ground surface at 0 up to, in this case, these tall trees here down right by the river are upwards of 50 or 60 meters tall, if that sounds right. And so if we zoom in on that, okay, and we rotate around a little bit and pan, okay, what you can see is that we indeed are getting some really, really tall pine trees up there. And so in this case, if we're interested in kind of the canopy height, this is one good way to do this, just as an advanced analysis technique. But if we're interested in just the points that are right above the ground, which is kind of a common analysis task, what we can actually do with this is go ahead and extract a range of values here directly from kind of that height above ground, so that cloud to mesh distance. So in this case, we want to go from 0 right at the ground to, let's just say we want everything below 5 meters. Okay, so 0 to 5 meters is our range. We'll say export, and that'll take a second. And you can see what we're left with here is just those values that are between 0 in blue and 5 meters in red. So this is kind of just the really low vegetation and the ground surface, essentially. And so this is just one more way that we can extract out if we wanted to look at, say, just the under canopy vegetation and strip off the canopy. This would be one way you can do that. It's This is actually a good way to look at features in the river channel as well. So things like large woody debris or riparian vegetation is to clip out the overhanging vegetation and just get these kind of low elevation values right above the ground surface.